Okay, this is Dr. Williamson. I'm going to solve homework problem 423, letter A. Says calculate each of the following quantities, and I'm just doing letter A. The volume in milliliters of 2.26 molar potassium hydroxide that contains 8.42 grams of solute. Molarity is moles of solute divided by liters of solution. What they're asking for is the liters of solution and then turn that into milliliters. With it, the concentration is 2.26 molarity and I have 8.42 grams. What I'm going to do is I'm going to rewrite this equation. I'm going to go moles of solute, and the solute is the stuff that gets dissolved. So in this case, the solute is potassium hydroxide. The moles of potassium hydroxide is equal to the, you know what? Let me resolve this. I don't want the moles of potassium hydroxide. I want the liters of solution. So the liters of solution, right, times the molarity will give me the moles of solute, which is the moles of KOH. But remember, I'm solving for the liters or the volume that I'm going to turn into milliliters. So I need to divide by both sides by molarity. So I'll have the liters is going to be equal to the moles of KOH divided by the liters of the solution. They gave me grams of KOH, not moles, but I can turn it into moles using the molar mass. So I'm going to go 8.42 grams of KOH times 1 mole of KOH is 56.106 grams. And I'm going to go here 8.42 divided by 56.106. And I'm going to get 0.150 moles of KOH. This is 1, 2, 3 sig figs. So this is 1, 2, 3 sig figs. I'm going to substitute that into there. And I made a typo mistake. This isn't liters down here. That is molarity. Excuse me. The liters is the moles over the molarity. So I have the moles. It's 0.150 moles of KOH. And the molarity is not zero, but the molarity is 2.26 moles per liter. So if I divide those, moles will cancel with moles. I'll be left with liters on the top. That's going to give me 0.0664 liters of solution. And I want to convert that into milliliters. So remember that 1 liter is 1,000 milliliters. And so this gives me 66.4 milliliters. So 66.4 milliliters. Oh, what am I doing here? Today's one of those days. Right, there I go. 66.4 milliliters is the volume in milliliters of that 2.26 molar potassium hydroxide that'll have 8.42 grams of solute. So what I did is I took the molarity equation, rearranged, and solved for molarity. Then I turned the grams into moles, and I put the moles right here, 0.150 moles. The concentration is 2.26 molarity, which is 2.26 moles per liter. If I divide that, moles cancel, I'll be left with 0.0664 liters. Convert that into milliliters, and I get 66.4 milliliters. Okay, I hope that helps. I'll do some more later.